Hey, last week we learned all about, through our POGO, we learned about electron configuration, this thing that you see here at the top, this 1s2, 2s2, 2p6, and we called it all sorts of different names, like first floor sunny rooms, second floor pink rooms, and we talked about bunk beds. But I want to go into detail more about what all of this is. In this case, it's kind of like a code, but the numbers in the code are actually kind of representing something called quantum numbers. And quantum numbers do have to do with quantum mechanics, that very kind of like fancy thing that you might think is very, very beyond us. And in cases it's very, very complicated, but we can talk about the basic quantum numbers. I'm actually not even going to give you the official name of the quantum numbers. I'm just going to describe actually what they do, because you already know what they do, because we've already talked about it. So the quantum numbers are pretty much just a way to give you an address for an electron. Now, an electron doesn't necessarily live anywhere, because it's always kind of like moving around, kind of like you guys don't necessarily always live at your home address, because you're sometimes at school, or sometimes you're out shopping, or you're at a friend's house. But it's the most likely location if we needed to find an electron. And so the quantum numbers are kind of like that address, like a street address or a zip code or the state. Again, it's just the most likely way to find an electron. So the very first quantum number is we call N, and that represents the energy level. And we have learned that in our electron configuration, that's the number that we write in the front. Okay, so that tells you if you see a 1s2, that means that electron is in the first energy level. If you come up here to the 3s2, then that means it would be in the third energy level. So that number represents the energy level. Okay, now there are 7 energy levels. So you can think of it as kind of like, here's our nucleus, and you have 1, 2, 3, 4, 5, 6, 7 energy levels. And each one can hold an increasing amount of electrons. And we'll talk about that in a little bit. But right now I just want you to know that, again, as you go farther away from, this is the nucleus, as you go farther away from the nucleus, they get bigger and it's higher energy to fill. We've already talked about that quite a bit. So an electron that's having to fill the 7th energy level is having to spend a lot more energy to do that than filling the 2nd energy level. Okay, so again, nucleus is in the middle, and the energy levels just kind of stack on top of each other in increasing energy. Okay, so that's the first quantum number, and that's representing the energy level. Our second quantum number, again, is something that we've already talked about, and this would be the sublevel. And the sublevel actually tells you, it's kind of a more specific area of where that electron might be. And we have so far learned them as S and P. Now, there's actually 2 more that we haven't learned about yet, and we're going to today. S, P, D, and F. Otherwise, you can know them as SPDF. S, P, D, and F. Now, each one of these have a slightly different shape. S is kind of a spherical shape. The P is kind of a dumbbell shape. The D is kind of a clover shape. And the F is just, we'll just call it kind of a wonky shape because it's too hard to draw. Okay. Now, our s orbital is by far our simplest, and we actually only have one. We only have one s orbital per energy level. You get no more than that. A sphere is a sphere is a sphere. You can only have one. However, the p orbital, we've already learned. How many bunk beds did we have in the pink room? 3. You have 3 p orbitals. The d orbital gets even more complicated, and you can actually, they take up even a bit more space, and you can put them in different configurations. You can actually get a total of 5. It's almost like having 5 bunk beds instead of 3 or 1. And then the f orbitals, you have 7. 7 wonky shaped kind of like orbitals make up the f sublevel. Now in every single one of these, they can hold 2 electrons. So if each one of these can hold 2 electrons, then that means every s orbital can hold a total of 2 electrons. Every p, because we have 3 of them, can hold a total of 6 electrons. D's can hold 10 electrons, and F's can hold 14 electrons. Okay? Now, we don't have every single one of these in every single energy level. S's are actually found in, you can find this in every single energy level. You can find them in the 1 through 7 energy level. You always find an S. So every time you start a new energy level, you start with an S. In the p orbitals, we don't start those into the 2nd energy level. The d orbital doesn't start till the 3rd energy level, and the f orbital we don't start until the 4th energy level. Basically, it's just as each energy level gets bigger, you can hold more orbitals, and you actually have to have them because that's what you're trying to find spaces for more electrons. Okay? So again, this is stuff that you already knew. We've already talked about this S, and that's referring to the sublevel. Okay? All right. The third quantum number is, we can think of it as the actual orbital. Because before we said, we'll say the actual space, or think maybe bunk bed. Okay? Because S is easy, because again, we just have one of those. Okay, so we don't necessarily have to say which S, because there's only one. But if you have a P sublevel, then you have 3 individual P orbitals. Okay? And the P is, because we said they're kind of like these infinity shapes, if you put them along an axis, X axis, Y axis, and then the 3-dimensional Z axis, then that's your 3 energy levels. So we call them PX, PY, PZ. Now the D's have the same thing, except it's 1, 2, 3, 4, 5, okay? And the F's have the exact same thing as well, except they are 7, 1, 2, 3, 4, 5, 6, 7. Okay, so again, you have 1, 3, 5, and 7. The only ones where I want you to really know the names of the actual orbitals are just the P's, X, Y, and Z. These get way too complicated over here in the D's and F's. We're not going to worry about the names of those, so just know that there are 5 and 7 of those. But know that P's there are 3 of them, and we're going to refer to them as X, Y, and Z. And so if we have a configuration that looks something like that, then this would be known as PX1, PY1. Okay? So that's just how you write it out, is PX1, PY1. Okay. All right, our very last quantum number that we've talked about is the spin quantum number. And that just talks about which way the electron goes. And you have 1 up and 1 down. It's showing you that 1 electron is spinning one way and the other electron is spinning the opposite way. What ends up happening, because you have 2, each electron is negative, they actually have to rotate in different ways in order to get the magnetic poles to go in opposite ways. So if they go in opposite spins, then that means they can actually occupy the same space. So that's all that means. Okay, I think that's explanation of quantum numbers, and we're going to move on with just kind of writing more electron configurations. All right, thanks. Bye.